Right, guys, welcome back. Could you comment your names so I can sort the register? So far we have Lucas. Anybody else out there? And Ollie, cool. And Isla, cool. I'll just go start doing the register now then. Okay, Oliver, Lucas, Isla. Alright, and we had Finn was there this morning, Sally was there this morning. So was Harry. Anybody else out there, or is it just the three of you today? Okay, just the three of you, I guess. Oh, and Ruben as well. Cool. All right. So we're going to continue where we left off on Friday. So we had these horrible questions today. How far did you guys get? Did you do any of these at home, or have you had a chance at any of these yet? I can't remember. If you have, I think we'll do the first two, and then I might give you guys some hints and some time to try and get through these six. These are the only ones I really want to do today, and then we're going to start looking at other topics tomorrow. So let's do the first two, and then I'll give you some hints for 15 through to 20, except 12. 12? Which one do you mean there, Oliver? Shall I scroll up, Ollie? Do you mean that one there? Yeah, do you mean this 12 here? Sine over cos of 7? Yeah, cool. All right. And Tom's here as well. Cool. Okay, we'll go through those top three there. So if we do 12, 13, 14 to start with, and then we'll give you guys some hints for the others. So 12 then. 12 isn't too bad compared to the others. I'm just going to upload a blank piece of paper, so there's something to write over. Cool. Right, there we go. Okay, so to do question 12, we've got sine over cos to the 7. What we need to do is write it out as sine x cos to the minus 7x. And then we've got derivative times the function to the power n. So we're going to try fx to the n plus 1. So we're going to try cos minus 7, minus 6x. If we differentiate that, we'd get minus 6 out the front, which we don't want, so we need to do minus a sixth there. We'd get cos power would go down 1, and we would get a sine come out the front. Yeah, so that's our answer there. 1/6 cos to the power minus 1/6 cos to the power minus 6. So that's how you do 12. Move these up. So 13 and 14. Okay, 13 is all about spotting. It's a double angle formula. So we've got 4 cos 2x. I'm going to split that up into 2 cos 2x times by 2 sine x cosine x. So 2 sine x cos x, that's the double angle for sine. So that I can write as sine 2x, which makes our integral 2 cos 2x sine 2x. And we can use the double angle formula again, realizing all of this is sine 4x. So we're actually doing the integral of sine 4. When we integrate that, sine's going to integrate to minus cos. Angle stays the same, and then we need to divide by 4 plus c. That's what we get, minus cos of 4x over 4 plus c. Cool. Okay, question 14 is another recognition question. And the trick to this one is realizing that the differential of cot is ln sine x. So cot f of x is cot, f dash x is ln sine x. So we've actually got here f of x to the power 1 times f dash x. So we need to try fx squared. So we're going to try cot squared x. If we differentiate that, we'd get a 2 out the front, so we need to divide by 2. Then that's it. So again, it's a recognition one, realizing we need to try cot squared. Wait, have I done this wrong? Have I done that might be right actually, because ln sine is yeah, sorry, I'm being an idiot. I've done that backwards. We want ln sine x squared. Then half that. Yeah, well spotted there, Ollie. That was a mistake I ever made. Yeah, cot is the integral of cot is ln sine x. I was thinking of the differential. Because the differential of cot would be cosec squared, wouldn't it? Cool, yes, that's our answer to 14. Damn, I think I made that mistake in my other group earlier and nobody spotted. Anyway, so those ones weren't too bad. The next ones are quite a bit harder. So I'd like you guys to try these for. I'm just going to go onto this slide and minimize that. Cool. So I'd like you guys to try the top 3. I'm going to give you hints because they are pretty horrific. So the first one there, how did I do that? Did all these earlier. I think the first one was substitution. Yeah. Second one here is think by parts. And in this one we can either use or substitution. There's two ways of doing it. You just got to be careful with each of these. They are pretty horrible. I will, to be honest, they are all quite horrible, but they're all doable. So I'd like you guys to try these. I don't want you to spend too long on each question. What do you reckon? 20 minutes to do the free? Maybe 18. That's 6 per question. If you spend more than 6 minutes on any question, skip it and move on. And then go back to it at the end. But yeah, I reckon 18 minutes to trial free should be good. Comment if you need any hints though. Just be careful. If you're careful and you follow the methods correctly, you should get to a correct answer. But they are quite hard, so there's a lot you could muck up. Be careful with your signs, especially with by parts, because you've got minus the integral. If you've got 2 by parts in a row, be really careful with brackets and your signs. With substitution, make sure you change all your x's into u's. And if you need to use a second substitution, you can always do that. Yeah, okay, give it a go. So 18 minutes on the clock, starting. Oh. Yeah, that's a nice way of doing it, Ollie. I didn't spot that. Yeah, you could turn that because it's one thing on one term on the bottom. You can split it up, yeah. Cool. Yep, that's another way you can do it. Yeah, 16 looks good as well, Ollie. Keep it up. Right, yeah, very. Like, I got it. Yeah, really well done. I'll have a rest you too if you did it. I don't know, but yeah, Ollie smashed it. Those are some horrible integrals. So well done. I think you're right. I haven't checked, but they look familiar. So okay, so let's start with this one. So I said substitution with u equals ln x. So we get so du by dx is 1 over 1 over x. So dx equals x du. So if we put it all together, we get 1 plus u over ux x du there. The x there is going to cancel with the x there, leaving us with 1 plus u over u. So that's 1 over u plus 1, which integrates to ln u plus u plus c. We know u is ln x, so we get ln x plus ln x plus c. If we wanted, we could use log rules and make it ln of x ln x plus c if we wanted there as well, which I think no, but you can do that if you like. Cool. So that's the first one. The second one is, what did I say it was? By parts. It's a horrible, long-winded by parts, this one, but you can do it. So, here we have u equals. Let's do the first one first, and then we'll do the second one. So u equals ln x. B dash is x. U dash over x is x squared over 2. So we get uv x squared over 2 ln x minus the integral of x over 2. You get x squared over 2 ln x. Take away x squared over 4. Okay, so that's our first one done. I'm going to rewrite this at the top so it's still there but slightly out of the way, because I feel it might come in useful later. Okay, second bit. We're going to have u is log x squared. B dash is x. U dash is 2 over x and x. And that's because of the chain rule. We've got to do the inside. Ln x goes to 1 over x. The outside, 2 comes down the front and it goes to the power 1. And then v is going to be the integral of x, which is x squared over 2. So we get uv minus v du dx, which is going to be x. Now that bit we already did. So my answer, basically, I didn't even need to do it. It would have cancelled out anyway. So this bit here, I remembered it came up somehow, but yeah. The bit that we just got to, iPad's raising. This bit here is that bit there, which is that bit there. So it's going to cancel out. This bit here will cancel with this bit here. So my overall answer is x squared over 2 ln x squared, which Ollie got, so well done there. Okay, last one, bit more horrible. There's 2 methods to do this. However I did this earlier, it took a while, so I do apologize for this. Bear with me, guys. Please pay attention because I could easily make a mistake in this one. I think I did when I did this earlier today. So, bring the iPad up here so I don't make any mistakes. So we got ln of ln x over x ln x. I'm going to do this by substitution, I think. Might be faster. We'll do both methods. So u is ln x. So du dx 1 over x. So dx x du. Okay, let's put it all together. So we get the integral of ln u over x u x du. So the x's there are going to cancel, leaving me with ln u over u du. Now, when I did this earlier, I did another substitution. I feel like we could probably do this by parts, but I might just keep going with it. I'm just going to do another substitution. So I'm going to say p is ln u. So dp by du is 1 over u. So my integral will become p over u dp. And the u's will cancel, leaving me with the integral of p dp. Integral of p will be p squared 2. P squared is ln u squared. And ln u is ln x. So we end up with ln x squared 2, which Ollie also got. Nice. So there you go. That's how you do that one. Cool. 2 substitutions. There is a by parts method as well, but that's... Is there a way to work out substitutions? The bit that makes it hard. So if you look over here, my first choice was ln u. Over here, my choice was ln x. And then when I got to this point, I was like, okay, let's do it again. And I chose ln again. Yeah, basically, if you get stuck, if by parts isn't working, stop, go back, substitute the hard bit. You can try and look ahead and think, what's the differential of the thing I'm choosing for you? Will that cancel out at all? So in this case, in the case here, we saw there was a u on top. You see, actually in both these cases, here we had it cancelling and here we had it cancelling. So if you can think ahead about what is this thing what is u going to differentiate to? Will that help me cancel something? If the answer is yeah, then it's a really good choice for a substitution. You can often do a few choices though. You can often pick a few different things as a substitution. I would never pick a product as a substitute. So I would never go for example, I wouldn't pick x ln x as my substitution because you have to differentiate that and then you have to use the product rule and it'd be a nightmare. You wouldn't get anything cancelling or simplifying. So I'd only choose single terms as my, or single x terms as my my u value. But it is really about practice and just kind of spotting what to do. I mean, a lot of these questions when I tried them earlier, I wasn't computer recognition. Yeah, you could have. Sorry, that's 1 over u differentiates to u. Yeah, you could have done that. Although 1 over u times ln u. Yeah, and what gone for u to the minus 2? Would that do it? No, because it's the wrong way around, isn't it? Oh, you'd have to, yeah, okay. Yeah, you could do recognition 1 over u times ln u, realizing that ln u differentiates to 1 over u. So you could try ln u squared, which is what we did, and divide by 2. Yeah, recognition. Sometimes recognition and substitution are interchangeable. Not always, but yeah, in some of these cases they are. It's just whatever you spot first. If you don't recognize it, you might do it by substitution. Recognition really is just a few substitutions that you've learned and you can learn to skip a few steps in. So that's all recognition is. It's recognition of a common substitution, really. All right, so there's 3 more, and 2 of these are right. The last one's horrible. It takes ages. So how long have we got? Yeah, this should be right. We've got time. So the last 3. Okay. So do I even need that now? Let's get rid of it. Cool. So I feel I should still give you hints. So first one is long division. Because it's top heavy, we got one thing on the bottom, so we're going to divide by it. Second one is a partial fraction. And the third one, you can either do by parts or substitution. Both take ages, both require 2 bits of by parts or 2 bits of substitution. It's horrible. Your answer will be horrible. It takes ages, but if you do it carefully, it was quite a worthwhile, rewarding integral to do. So yeah, I'll give you guys 20 minutes for these, and then this will be all we do today. Then tomorrow we're going to move on to area integrals. So 20 minutes on the clock. Start now. Comment your answers and ask me if you get stuck. Cool. Right, time is up. So first one, long division, not too bad. Oh, I just missed a load of comments. Sorry, guys. I can't remember honestly. I felt like it was 112, but we'll see we'll see when we do it now. So long division for this one. We're gonna get x on top, x squared there, plus 8x. Minus 5, take 8. It's going to be minus 13x. Yes. And then the 6 just goes there. Minus 13 up there. 13 times 8. It's going to give us 104. Wait, what am I talking about? Being an idiot. Minus that, add them together and get 120. So neither of you are right. Is that what we've come to? Is Ollie right? I make it. Oh, 110. 110. Years 110. Sorry. Yeah. Right. Cool. Yeah, Oliver. Yeah, you are right. Cool. Okay. Yeah. So let's do this. So if we get rid of all this stuff, we basically found that it goes in x minus 13 with a remainder of 110 over x plus 8. So now we can just integrate all this. We get x squared over 2 minus 13x plus 110 x plus like that. Yeah, Ollie. So you're spot on there. Okay, question 2, partial fractions. So factorize the denominator. I think it's going to be 3 and 2, minus 3 and minus 2. So x plus 8. Get that? Cross multiply. Yeah, x plus 8. A, x take 2, b, x take 3. Let x equal 2, so we get 10 equals minus b, so b is minus 10. Let x equal 3, so we get 11 equals wait. I feel I've done something wrong. Oh, x equals a. Yeah, cool. So 11 is a and minus 10 is b. So let's put those in and do the integral. So we get 11 there, minus 10 there. Integrate it all. 11, then x take 3, minus 10, then 2. Yeah, good. Well done, Lucas there. Okay, on to the last question. Which is the worst integral in the world? So, yeah, by parts or substitution. Neither are fun choices to make. Let's do substitution first of all. So I'm going to say u equals log x. So du by dx over x. So dx is x du. So the integral becomes u to u x cubed u. Dx there is going to cancel with that to make it squared. We get integral of u x squared du. Okay, we need to change that x squared into a u. The way we're going to do that is with this equation here. So u is ln x, therefore x is e to the u. So that bottom bit is going to become u 1 minus u e to the 2u du. Okay, let's make space, put it back at the top. So I'll keep my original substitution there. So integral of, I'm going to expand all this, so we're going to get u minus u squared over e to the 2u. I'm now going to bring the e to the 2u up and times it all out. So we're going to get u e to the 2u minus u squared to the 2u du. That is two sets of by parts. So I'm going to write it to the top and probably write it quite small so we can try and fit this in. E to the 2u squared 2u du. All right, so for the first one, u can be u, b dash can be 2u, u dash 1, b is a half 2u. So put it all together, u over 2, e to the 2u minus the integral of a half to the 2u. So we get u over 2, e to the 2u minus a quarter to the 2u. So that is the first part there. Is negative 2u. Yeah, it is. Okay, thank you. Spotted. Okay. It could be worse. There could be worse things that have happened. So we need a minus there and a minus there. That's going to be a plus. That's going to be a minus. That's going to be a minus. And overall, it will. Cool. Do you guys agree with that? Sorry, I've done this a lot today. Well spotted. Cool. I think that's right now. Let's go for the next bit then. So here we're going to say u can be minus u squared. B dash can be e to u. U dash can be minus 2u. B can be minus a half to the 2u. So then we get uv. So that would be u squared to 2u minus v du dx. So the half and the 2 are going to cancel, so we get u to u. So again, I need to do by parts on this one. Oops, still need a minus. What are we doing? Okay, now, interestingly, we've got back to where we started. You see this bit in red is the same as this bit in red. So my answer, if we basically work this out, the whole integral becomes this bit, take away this thing, take away the same bit we started with. So we're going to get this plus that. Now I feel like something's meant to cancel here, but maybe I've made a sign error. Have any of you guys done this one? I feel like there's a sign error, but I'm not sure. This happened when I did this earlier today as well. No. Okay, that's why. Okay. It's not this take this, is it? It's this take all of this integral, which is actually this bit worked out as positive and this bit worked out as negative. So it will cancel. This minus sign is not actually, it's that I've included here. So it's actually this plus all of this integral here. So that bit there plus this, take this. So our whole answer is going to cancel down just to be u squared over 2 e to the 2u. Now, u is ln, so we're going to get ln squared over 2 e to the 2 then x. Should be a minus there though. Yeah, because I'm forgetting minuses everywhere today. Minus in there. So we need to sort out this bit with log rules basically. If I get rid of everything else, we will get ln of x all squared over 2 e to the, if you make x to the minus 2, it's going to be e to the ln 1 over x squared. Those are going to cancel, so we get ln of x ln of x all squared 2 times by 1 over squared. So we can say it's ln of x squared 2 squared. Yeah, cool. Well done. I'll leave there. Okay, we've got 15 minutes left. Do you guys want me to do the other bit by parts just to show you it's the same? Yeah, go on. We'll do the other bit by parts then. And then we'll call it a day. Last one's horrible. That's the second time today. That time I didn't make a sign error. I just read it very quickly at the end there. But when I did it earlier, I made a sign error on that. So we're going to basically just split the integral straight away into ln x over x cubed minus ln x all squared x cubed. So I've expanded the brackets to get ln x minus ln x squared and divided both by x cubed. So basically we can turn this into two separate integration questions and do both by parts. So we're basically talking x to the minus 3 ln x minus x to the minus 3 ln x squared. So both of these need to be done by parts. So yeah, we'll do the first one first again. So u is ln x, v dash is x to the minus 3, so u dash is 1 over x, v is x to the minus 2, 2. Put it together, minus x to the minus 2 over 2, ln x minus the integral of v du dx, which is minus x to the minus 3, 2. And if we do that integral, minus x to the minus 2 over 2 ln x, that's going to go to the minus 2, divide by minus 2, so minus 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 is a minus overall over. So that's what I get for the first bit, the first term. Yeah, I've expanded that, Lucas. Hopefully that makes sense now. So I've expanded the brackets. Ln x times 1 is ln x, ln x. Yeah, cool. So that's my first bit. Next bit, I'm going to keep the minus sign this time in the middle because that got confusing just now. I'm going to use u equals ln of x all squared and dv dx, or v dash let's call it, is x to the minus 3. The u dash 2 over x ln x. V is going to be x to the minus 2. So put that integral together to get uv, so minus x to the minus 2 over 2 ln x squared minus the integral of v du dx. That's going to be plus 2's will cancel. We get x to the minus 3 ln x, which if you look is exactly what we started with. Look at the green, that is the same as what we had up there. So if we follow me, I'm going to go through these signs now and make sure this is clear. We've got the green bit, which is done here, which I didn't actually need to do. Take away this bit. Take away, that's going to be a plus. Take away this bit, so that bit there is going to cancel with that bit there, leaving us with just minus and minus this bit here. So just to write the answer then, we're going to get then x all squared. I'll bring the x down at the bottom now, 2x squared, because that cancels with all that minus turn into a plus. There we go, cool. Actually, that wasn't too bad. It was a lot worse when I did this earlier today, but yeah. Right, has anybody got any questions about any of these integrals we did today? I know they're completely horrible. The plan tomorrow is to do area integration. Friday, we're going to look at vectors. I was speaking to my other group. We've got 8 lectures left. They said they wanted to go over these topics. What else would you guys like to go over? Is there anything additional to this? Because I don't want them to pick all the stuff that we do. So I'm definitely going to do the areas and the vectors. I'll definitely do proof. I think functions is probably a good idea. The other 3 we can do, but are there anything that you guys might want to focus on instead? Any other topics for revision? Right, I'll give you 2 minutes now. Have a quick think and type any topics that you might want to go over. And then we'll add those to the list. So 2 minutes now. Have a quick think about what else you might want to do. Okay, yeah, that's a good one. Are they drawing graphs without a graphical calculator? How to draw graphs. Yeah, right. That sounds good. Cool. Anything else you guys want me to go over? So maybe I'll throw trig graphs in there. Okay. If you do think of anything else, let me know. You know, I've already planned tomorrow and Friday, so let me know by Friday if you do have any other topics you want me to go over, and I'll start working them into plans for next week. Otherwise, we'll call that a day for today. Cheers, guys. See you tomorrow.